All right, here's another Add Math lesson, and we have two more lessons until we finish the topic of algebra. This topic is going to be remainder theorem. And once you understand the remainder theorem, I will show you how to use the remainder theorem to solve some problems that you're going to encounter. All right, so let's start off by first putting the title. And we're going to put it here. We're going to be learning the remainder theorem. And let's do a formal definition of the remainder theorem. So if a polynomial p of x I should say, is divided by x minus a, then the remainder r is equal to p evaluated at a. So let me write that as a formula. We can say, let me just put this in orange, we can say that the remainder is equal to p evaluated at a. Now, we can prove this, right? We can prove this. Well, we can reason this out, right? Let's do a little bit of note on how we can reason this out, and you can see why we say this. So we can say that when you divide by a polynomial p of x by a, when you divide, not a polynomial, let's say d. So when you divide the polynomial p of x by a linear divisor of the form a minus x minus a, the remainder theorem states that the remainder is simply the value of the polynomial evaluated at x equal a. Let's go back to when we were doing division of polynomials. Remember when we were doing division of polynomials, we said that what we're doing is we're essentially taking p of x, a polynomial, and dividing it by x minus a. And once we recognize that that division is done, we would be able to get this polynomial here plus a remainder, and this is divided by x minus a here, right? And I should put this as r, right? Now, if I decide that I'm going to multiply throughout by x minus a, then I can see right away that this is going to give me p of x is equivalent to x minus a into q of x plus the remainder. Now this remainder can be found at a situation where x is equal to a. So when x is equivalent to a, then p evaluated at a would be equivalent to a minus a times q evaluated at a plus r. Now this here doesn't matter. This is equal to 0 because a minus a is 0 and 0 by anything is 0. So what we get is that the polynomial evaluated at a is equal to the remainder. So this is the basis of the remainder theorem. All right. Now let's look at some examples of the remainder theorem in use, and you'll see exactly what we're doing with it. So instead of going through all of the divisions and finding the remainders, what we're going to do is we're just going to simply use the remainder theorem and figure out remainders. So example 1, we're to find the remainder when p of x, which is equal to 2x cubed minus 3x squared plus x minus 5, is divided by x minus 2. Now usually what you would do is you would take this and you would use long division or you'd use synthetic division and be able to get your remainder. what I'm going to do is I'm going to do a different method, which is to use the remainder theorem to find the remainder. And then I'm going to use synthetic division and show you that the remainder is the same. So let's see. Since the divisor is x minus a, then a is sorry, I shouldn't put a. Since the divisor is x minus 2, then a would be equal to 2, right? Since we're following the form, we're trying to have it in the form of x minus a. So since the divisor is x minus 2, then a is equal to 2. Then p evaluated at 2, well, I should say p of a, p evaluated at a would be the same as p evaluated at 2 in this case, which is 2 into 2 to the third power minus 3 into 2 to the second power plus 2 minus 5. Working that out, we're going to get 2 twos, 4 twos, 8 twos, 16 minus 2 twos, 4 by 3, 12 plus 2 minus 5. Usually when I'm doing this, I tend to group terms together, that positive and negative. So I would group these together and get me 18. And then I'll group these together and I'll get me negative 17. And I'll get my answer as right away 1. Now, I said that you're supposed to get the exact same thing. I'll just put this here. Therefore, the remainder is 1. Now, I'm saying you're supposed to get the exact same thing if I do the long division. Let's do the long division. Sorry, not long division, synthetic division. I don't want to do long division because synthetic division does it faster since I have the divisor in this form. All right, so let's do the synthetic division. So we have, I'm going to put that in yellow, right? Let me put it in blue. So I'm going to take the same thing here. So 2, negative 3, 1, negative 5. So 2, negative 3, 1, negative 5. And then I'm going to do the synthetic division, and the division is going to be with a equal to 2. So 2 outside here. So I'm going to bring down the 2. Then I'm going to multiply these 2, which is 4. Add these 2 together, which is going to be positive 1. Multiply these 2, which is 2. Add these 2 together, which is 3. Multiply these 2, which is 6. Add these 2, which is 1. Now remember, the quotient is going to be, well, the result is going to be as follows. We're going to have, since this is going to third power, this is going to be 2 to the 2x to the second power plus x plus 3, and then a remainder of 1 over x minus 2. All right? So that is the answer that you would get when you do the division. So you can get the remainder with the remainder theorem. And for situations where you can't use synthetic division, this will come in very useful. All right? But in most cases, you would be able to use the remainder theorem to get your remainder. Let's look at a couple of examples where we can use the knowledge of the remainder to solve for an unknown coefficient. Let me just put in this here, and let's go with the next example, example 2. And we can say that given that the polynomial p of x is equal to x squared plus kx plus 3 leaves a remainder of 5 when divided by x minus 2, find the value of k. All right, let's see if we can find that value of k. So the divisor x minus 2 implies that a is equal to 2. So the remainder and the remainder r is equal to 5. So this is two pieces of information that I got from the question itself. Next, I'm going to apply the remainder theorem. Applying the remainder theorem, I know that p evaluated at a is going to be equal to my remainder. So that means P evaluated at 2 is going to give me 5. P evaluated at 2 is going to give me 2 into, well, 2 to the second power. You can see it here, 2 to the second power plus k by 2 plus 3 plus k times 2 plus 3. And that would be equal to 2 2s are 4 plus 2k plus 3. And this here is 2k plus 7. Now I know that this is supposed to be equal to 5. But P of 2 is equal to 5. So 2k plus 7 is equal to 5. That means 2k would be equal to, and I'm just going to minus 7 from both sides. So I'm going to minus 7, and this is going to be 5 minus 7, which is minus 2. And then I'm going to divide both sides by 2. Divide by 2 both sides. Once I divide by 2 both sides, this is going to take k, and it's going to be negative 2 over 2, and that's going to be negative 1. All right? So in other words, the value of k is equivalent to negative 1. Let me just double check my answers because I may have rushed and made mistakes. Let's see. So 2 2s are 4 plus 3, it's 137. So I have 7, nice, and then minus, and then, yeah, great. No issues there. Let's go to the third example. All right. Now, I assume that you know already how to solve for an unknown variable by simply subtracting or minusing for both sides. And I took that for granted. If it is that you don't know how to solve for an unknown variable yet, let me know. I will create a small video for it, and that will help with the problem. And just to account for that fact that I didn't really teach something like that, in the next one, I'm going to take my time when it comes to doing the solution of this. All right. Let's do the last one. Example 3. And we can say determine the value of k if p of x is equal to 3x cubed plus kx squared minus x plus 4 leaves a remainder of 0 when divided by x plus 1. All right. So the divisor x plus 1 implies that a is equal to negative 1. And the remainder, let me just say, and the remainder is r equal 0. So I'm going to be applying remainder theorem. So I'm applying the remainder theorem Right, so I'm applying the remainder theorem, and I know that I need to evaluate p of negative 1 is going to be equal to 3 into negative 1 raised to the third power plus k into negative 1 raised to the second power minus negative 1 plus 4. All right, let's do this now. So 1 to the third power is negative 1 by 3 is going to give me negative 3. Negative 1 to the second power is positive 1 multiplied by k is going to give positive k. Negative 1 by negative 1 is going to give me a positive 1. So I'm just going to say positive 1 and then plus 4. Simplifying this, I'm going to get that this here is 5 minus 3 is going to give me 2 plus k. All right, so p of 1 is 2 plus k. We go on next page now. Now, p evaluated at negative 1 is supposed to be equal to the remainder of 5, right? But p of negative 1 is equal to, oh, not 5, sorry. I think it's 0. Let me just make sure. The remainder, yeah, remainder is 0. So p of 1 is supposed to be equal to 0. That means 2 plus k is equal to 0. 2 plus k is equal to 0. Now, at this point, let me take my time and show you how I do this. I am identifying what I want to find. I want to find k, right? What is being done to my k? To my k, I am adding 2. Okay, so if I'm adding 2 to k to get 0, then I'm going to have to reverse that operation, which is minus 2. So I minus 2 from the operation, and I would see that I have to minus from both sides. So I'm going to say 2 plus k and equal to 0, and I'm going to minus 2 from both sides, and I'm going to see that these two here will give me 0, and that is basically your additive identity, right? If I add 0 to anything, it will give me back the same thing. So I'm using the additive identity to solve the problem. So I'm just going to say 2 minus 2 is 0, so I'm going to remain with k, and if I take that minus 2 from the side, I'm going to get minus 2, so k is minus 2. All right? Now that you understand how to use the remainder theorem to find unknown variables and how to use the remainder theorem to find remainders, let me give you 5 problems to try, and I'll also go through the steps in solving them. If you want to ignore the steps, you can just simply pause the video or stop the video as soon as I'm finished writing the problem. But I'm going to write out all the problems and tell you how to go about solving each of them so that you'd be able to have the answers. I'm not going to give you answers. I think it's better for you to struggle a little bit and work problems out rather than get it. You won't understand it as much as when you try to solve the problem on your own. Let's see, problems. The first problem that we have is to find the remainder when p of x is equal to x to the third power minus 4x plus 6. This is to the second power, by the way. And then we have is divided by x minus 3. Then the next one, we're going to say that given that p of x is equal to 2x squared plus mx minus 5 leaves a remainder of 7 when divided by x minus 2. Find the value of m. Let's go on to the next one. 3. So if p of x is equal to x to the third power plus 3x squared plus nx plus 9 leaves a remainder of 0 when determine the value of n. All right, let me just give you some challenging ones as well. All right, so determine the remainder when p of x is equal to 4x squared minus x plus 2 is divided by x plus a half. All right, and then the final one, let me just give you a last one. So find the value of k such that p of x is equal to x squared plus kx plus 1 leaves a remainder of 4 when divided by x minus 2. All right, so let's go about giving you some hints to solve this. So this here is very much similar to example number 1. So just follow example number 1 and you'll be able to solve this. Part 2, again, it's very much similar to example number 2 in this case, and you just have to follow the format and solve it. What you have to do is identify what is being done to the variable m, and once you identify what's being done to the variable m, you just reverse it. right? So let's say, for instance, I notice that 2m plus 6 is what's happening. I notice that what is being done to the m, first off, the m, let me just write it here, the m is being multiplied by 2, all right? So I'm going to multiply that m by 2, and then I'm adding 6. So what I have to do is I have to reverse the order of the operations, reverse it, and I can see right away that it's going to be minus and 6 to reverse that, and I'm going to divide by 2 to reverse that. So as long as you work backwards and you reverse the operations that happened to the variable, you'd be able to solve for that variable. And again, if it is that you're having problems to solving for a variable that you don't know, just let me know and I'll do a video on solving equations. And then number 3, it's the exact same thing as example number 3. Number 4, it's the exact same thing as example number 2 and example number 3. But in this case, we have a fractional value here, so you're going to get negative a half, and you're going to have to work with fractions in it to solve the problem. All right? That shouldn't be too much of an issue. This one here, very simple as well. So find the value of k. So again, it follows example number 2 and example number 3. All right? So I'm just going to put that here. So 2 and 3 is the ones that you can look at to solve this. 1 is the one that you can look at to solve this. 2 and 3 is the ones that you can look at to solve this. And then similarly, 2 and 3 that you can look at to solve this. And then 1 for this one here. Right? So just look at those examples and you'll be able to solve these problems with very easily. All right, so that's it for this lesson on remainder theorem. I'll see you tomorrow for the next session, which is going to be about the factor theorem.